today, lesson 4 here, we're going to talk about cyclic hydrocarbons or cyclic hydrocarbons. Cyclic hydrocarbons. As the name implies, basically you're going to have a ring together. Okay, so kind of a circular kind of structure to it. They include cycloalkanes, cycloalkenes, and or cycloalkynes. So we can still have single, double, triple bonds in those rings there, basically. To name these, you want to use, of course, the same kind of naming that we used before. Pentane, for example. Well, if we organize those into like a ring structure, we're going to call it cyclopentane. Okay? Or if we had pent-1-ene before, we're going to just put cyclo in front of that. We're not going to actually put numbers with the double bond or the triple bond in this case, and I'll explain why in a second here. But we're just going to put basically the word cyclo in front to mean that basically instead of a long chain stretched out, we're going to make it a ring. Okay, so we're going to connect them back together again. So you're going to use the word cyclo in front of that root, pentane, pentene, pentyne kind of thing. The suffix is based on the bonding in the ring. A double or triple bond is always between carbons 1 and 2. That's important. So if you got a double or triple bond, it's always part of carbon 1 and 2. Okay? Always, always. Branches listed in alphabetical order as always, and once again you have to get to the branches as quick as possible, just as always. Okay? So you have to use the lowest numbers possible, of course. Okay? To draw these, you're going to use line diagrams. Okay? Line structural diagrams. So you're going to basically, that mountain thing that we did the other, remember back a while ago. Well, we're not going to do mountains anymore because we're not going to go up and down because we're going to join them in a ring together. So we're going to be thinking of things like triangles, squares, pentagons, hexagons, heptagon, octagon. Step into the octagon. I heard it once. Decagon. That's tough to draw. Okay. Branches are condensed structural diagrams. So condensed is what we did. CH2 dash CH2 dash CH2 dash CH3 kind of stuff. That's condensed structural diagrams. They kind of look like this here, of course. Okay. So we're going to name these here. So, like I said, we got basically a ring here. It's all joined together. We can start numbering some carbons here. 1, 2, 3, 4, 5, 6 carbons right there. So in there in a cyclo kind of cyclic kind of feature here. So this is called cyclohexane. 6 carbons, of course, all single bonds, yes. So hexane. And we have a CH3 added onto that, so we of course remember that that's called a methyl group. So we're going to call this methyl cyclohexane, all one word still. Okay. We don't need a number with the methyl group, so you might say, well, do I need to put a 1 there for 1 methyl? And the answer is no, because it doesn't matter where you put that methyl group, it's going to be considered to be number 1, right? I mean, you might say, well, I want this carbon to be number 1. Well, it is, because it's the lowest number possible. And you might say, well, how is this different than if I had the methyl group over here? Well, the answer is it's not, because that would be carbon 1 then, right? It doesn't matter where you put that methyl group on, it's going to be on carbon number 1, okay? Because remember, these are 3-dimensional drawings, so if you simply turn them, right, you want that methyl group at the bottom, you just turn it a little bit, and it's at the bottom. Okay, you flip it over, it's on the other side now. So, you don't need a number with that one, because there's only one spot it can go. It has to go on the number 1 to make it the lowest number. Okay? This one here, though, let's take a look at this. This does have a double bond in there. So, first of all, cyclic feature again here, so cyclo. Okay? 5 carbons, right? Look, there's 1 there, 2, 3, 4, 5 carbons. So that's pent. It's got a double bond, so that's ene. And I don't have to put a number with the double bond because I know that in a cyclo kind of structure here, those are always going to be, the double bond is always on carbons 1 and 2. So that's given. So it's always on 1 after the first one, basically. Okay? The question becomes, though, which way are you going to go to name the rest of these add-on groups using the lowest numbers possible? Are you going to go 1, 2, 3, 4, 5? Or are you going to go 1, 2, 3, 4, 5 with the green ones is the options. And remember, that's going to determine which way basically you're going to draw this or name this, right? You want to use the lowest numbers possible. So I think we probably should go with what? Probably the red ones, yes? 1, 3, and 4, yes? If you went with the green ones, it's going to be 2, 4, and 5, right? So we want the red ones here. So we're going to go with, let's see, 1 has methyl, 4 has a methyl, okay? 3 has an ethyl. We think about alphabetically, right? Ethyl, and we have methyl. You want the ethyl one first, yes, because it comes first. So 3 ethyl. And then 1 and 4, oops, that's a 4. 1 and 4 have dimethyl cyclopentene. Okay, so 3 has an ethyl, 1 and 4 have methyl, so we call it 1,4-dimethyl. Okay, and then of course cyclopentene. Yep. No, because the 1 and 2 always have to be on the double bond. Yeah. Okay. Questions, anyone? All right. Okay, moving on here. Hey, let's name this one here. Let's see here. How many carbons we got here? 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's cyclo, of course. Oct, all single bonds, so octane. Cyclooctane. Okay. Then we look here, and you got to use the lowest numbers possible. Obviously, you want to start, you know, if you can you use ones in this case? Sure you can, right? So, I mean, the option is this is 1 here and that's a 3 there, or 1 there and 3 there is going to give you the lowest numbers possible. I mean, can you start? Could you put the carbon somewhere else? Yeah, you could, but or carbon number 1, sure you could, but it's going to not give you the lowest numbers possible, right? I mean, it could end up to be 2 and 4, or 3 and 5, or something like that. This one here, that's going to be 1 and a 1 and a 3, so that's probably what we should go with. Otherwise, it's going to be 1, 3, 3. So let's go with 1, 1, 3. And of course, ethyl comes before methyl, so it looks like we're probably going to go with 3 ethyl, 1, 1 dimethyl cyclooctane. Okay, so 3 ethyl, 1, 1 dimethyl. Alphabetical, using the lowest numbers possible. So 2 1s and a 3. All right. Good. Questions, anyone? Questions? All right. Let's draw these. I'll give you guys some time here. You guys go ahead and draw these. Okay, methyl cyclopentane. Cyclopentane. So 5-sided figure. Cyclopentane. And you need a methyl group on there. I'm going to put mine there. You can put yours wherever you want. Don't care. 1 ethyl 3 propyl cyclohexane. So cyclohexane. That's a 6-sided figure. Something like that there. 1 ethyl. Ethyl is 2 carbons added on. And then 2 spots away on the 3rd carbon, you need a propyl. Yeah. I'll do it down here. And there's the propyl group for you. Okay. Propyl, of course, is 3 carbon add-on, right? And the last one here is methyl cyclooctene. Octene, oh geez. All right. Sure. I have some artwork for sale, in case anyone's ever interested. Cheap, pretty cheap. I don't like to give it away, but okay. Let's make a double bond here. All right. So there's my carbons 1 and 2. I'm gonna choose. Let's see. I'm gonna choose this as my 1. So that's 1. Don't forget though. Once you choose that as 1, okay, sometimes I get people doing this. Oh, there's 1, so now I'm going to go this way, 2, 3, etc., etc. No, no. It's always between 1 and 2. So if this is 1, that's 2. Okay, if you're going to do it the other way, that's fine. That's always 1 and 2. Okay, so now that I chose that, that's 1, 2, 3, 4 is an FO group. Okay? So something like that would be okay. That's 8 sides there in case you can't tell. Yeah. Yeah. Carbons 1 and 2 always have the double or triple bond. Yeah. Okay. Good? Yeah. So this isn't too bad, eh? All right. Next. We're going to talk about aromatic hydrocarbons. Aromatic hydrocarbons. They're smelly. Aromatic compounds are all based on the presence of a benzene ring. 6-carbon ring with 1 hydrocarbon. So benzene is actually C6H6. Looks something like that there. Okay. Originally, they thought benzene was thought to have alternating single and double bonds. So they originally thought it looked like this here. Okay. Where you'd have double, single, double, single, double, single, and alternated. That's what their original thought was. Then they did some tests with that benzene ring and found out that actually all those bonds had the exact same length, basically. They're identical in nature, and they didn't react with bromine, which is something we'll do a little bit later here when we do these tests with basically single and double bonds and triple bonds and things like that. So that's part of the reactions that are coming up with this unit here. So there was a lack of reactivity with bromine, basically, which basically meant that there's probably no double bonds there present. So what they found was, instead, each carbon has delocalized electrons. So instead of having double bonds inside of that ring, those electrons are delocalized and they're free to be shared in the middle of those rings. Okay? So they are shared collectively by the molecule, by the various atoms. So this is what benzene actually looks like here, and we represent a benzene ring with a circle in the middle to represent these delocalized electrons. So these are delocalized electrons inside of here. All right? So when you see that, you'll know that's probably a benzene ring. One more thing I need to add on here. Benzene is C6. You should write this down somewhere perhaps. That's what benzene looks like, okay, if you're actually to draw it out completely. Every carbon, of course, at the junctions there, only has 6 hydrogens attached to it. Those extra electrons that you would have in here are in the middle here that are kind of floating around, free to be shared collectively inside of that ring there, okay? So that's actually what benzene looks like, okay? It's only got six carbons and only 6 hydrogens bonded to each one of those carbons. And of course, the carbons are here, oops, here, 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 and here, okay? That's your C6H6 there, okay? So that's important for later on here. All right, 2 definitions you need to know. Aliphatic hydrocarbons or aliphatic hydrocarbons can be classified as alkanes, alkenes, or alkynes, so basically the first ones that we've drawn so far, those long chains, okay? So pentane is an example of an aliphatic hydrocarbon, okay? Pent1-ene, pent1-ine, all those are examples of aliphatic hydrocarbons. So anything we've done so far without the benzenes thing, okay? So anything like that, like cyclopentane, cyclopentene, cyclopentine, all those are examples of aliphatic hydrocarbons, okay? Aromatic hydrocarbons are characterized by the presence of the benzene ring. So if you have a benzene ring there somewhere, we call those aromatic hydrocarbons. Make sure you know the difference between those two, because there's always questions on the diploma and on the unit tests that tell you which ones of these are aliphatic, which ones of these are aromatic. Okay? Always. Guaranteed. Okay? So, aromatic, of course, includes the benzene ring. If you're naming and drawing aromatic hydrocarbons, the root of the word, so instead of saying, the root of the word is always going to be benzene, okay, when it has that benzene-looking structure to it. The carbons are numbered to locate the side chains, of course, as quickly as possible, as always. And here's some examples, okay? There's no cyclo here, because we know that benzene is this cyclic kind of structure to it, okay? So there's no cyclo. This is, of course, in this case here, this is the benzene ring. Okay, right here, benzene with this circle here, and we got a methyl group that's added on. Once again, we don't have to be specific where that is, because of course we're going to assume that that is the first carbon there. So it's methylbenzene for that one. Okay. This one here we're going to have to be a little bit more precise with, because we do have a couple of add-ons here. Once again, you'll see the benzene ring. We don't need cyclo, because once again, benzene is a ring, carbon, C6H6. So it's going to be benzene. And we want to go lowest numbers possible. So I guess your options are, let's see, 1, 2, and 3. Or I guess you could start here, 1, 2, and 3 if it makes a difference. Doesn't make a difference? Sure it does. We probably should be, right? You might say, well, what's the difference, 1 and 3 or 1 and 3? Well, same numbers, but remember, is one alphabetical? Which one are we going to write first? Methyl or ethyl? Ethyl comes first, so we probably should give that one the lower number. So let's go 1 ethyl, 3 methyl benzene. Okay? So alphabetical, and in this case with the lowest numbers. Yep. Yeah. Okay. So 1 ethyl, 3 methyl. Let's go ahead and draw these guys. Go ahead and draw those. Okay. So there's ethylbenzene. Ethylbenzene. And 1,3-dimethylbenzene. So, and 1 and 3 have methyls, I guess. And I chose to put them there. As long as they're 2 away, that's fine. So there's 1,3-dimethylbenzene. Huh? No. No. Okay. Now, in more complex structures, you can add this benzene ring onto a long chain of carbons. So you'll notice here we kind of have, this is the main feature, and of course we have these CH3s coming off there, or that one off of there. Okay, so we can do that, right? We can also do the reverse, where those benzene rings are add-ons to a long chain. Okay, so in more complex structures, the benzene ring is named as a branch, so you can actually put it onto a long chain of carbons. And in this case, we're going to change the name from benzene, because that's not the main feature anymore. We're going to call it what we call the phenyl group. Okay, so that benzene is going to change to what as a name as a phenyl group. Okay, so next one here, we got something that looks like this here. Okay? And we'll go through this first, and then I'll kind of show you some differences between what we just did and this stuff here. So first things first, you notice we have more than one benzene ring. So the benzene ring is not the main feature here. We got more than one. Okay? So I have to name this as a long carbon chain here. How would you know which benzene ring is the main feature? If that was in fact the case, you wouldn't. Okay, there's two of them added on, so we don't know which one would be the main feature, and I'll show you some other problems with that as well as we go through this. So we're going to name it as an add-on group. This is what? 6 carbons, so that's hex, single bonds, hexane. You want to use the lowest numbers possible to describe these add-on groups. Well, I would probably start at this end, yes. 1, 2, 3, 4, 5, and 6, of course, would give me the lowest numbers for those add-on groups. On 2, I have a methyl, and on 3 and 5, those benzene rings have been added onto this chain, so we call them phenyl groups. So we're going to call this, let's see, what comes first? Methyl, I guess, yeah? Methyl and phenyl. Methyl. So I'm going to call this 2-methyl. And 3 and 5 have phenyl groups, so I'm going to call that 3,5-diphenyl hexane. Okay, so 2-methyl, 2 has a methyl group, 3 and 5 have phenyl groups. Yep. Alphabetical.
Yeah, but can you go like 2 and 4?
Nope, because you got to do the lowest numbers possible. Okay, so there's that one there. This one here, most certainly you'll see, okay, you don't really have an option in this case. Well, you don't have an option in the other one, but look, there's a double bond here. There's no way to name an add-on group. So if you said, oh, this is a benzene ring with an add-on, how do you describe the add-on when it has a double bond? We've never done anything like that, right? It's impossible. So the main feature here, of course, is the double bond. In this case here, so what is that, 4? So that's bute. You have to tell me where the double bond is because it's a chain here, so it's on the second one, no matter which way you go. That's butene is the red part there so far. Okay, you have to tell me where the double bond is, of course, in this chain. Then, you know, you have an option. Which end do you want to start with? Well, probably this one because it gives you lower numbers, right? 2, 3, right? 1 and 3 have phenyl groups, so we'll call it 1,3-diphenyl. That's all one word, butene. 1,3-diphenyl butene. Okay. Now, you might say, oh, I don't know. How do I know if it's a benzene or a phenyl, right? How do I know that? Well, in this case, of course, you got 2 benzene rings, so those are probably 2 phenyl groups, right? I mean, hopefully that's kind of a little bit more obvious, because otherwise, which one are you going to call benzene? Which one are you going to call a phenyl? Don't know, right? So you got to decide if they're add-ons or if that's the main feature. Well, look, this kind of tells you most of the time, but you know, something like this here, for example, well, I'd say that benzene's the main feature. Yeah. What if you'd had something like this here? Whatever, and then. So you kind of got to decide, right? How am I going to name it, right? Look, with that one, it's pretty obvious. I think that's benzene, and there's a little group added onto that, or maybe even another little group over here, right? Now, for sure, I could tell you that that benzene is the main structure, because how are you going to describe the other part to that, right? There's no chain that's going to, there's no long chain there that you're basically going to say, oh, that's ethane. But how are you going to describe the methane that's also there, right? Or that methyl group? It's impossible. This one here, though, look where the carbon's attached to here, right? This is attached to this one here. Well, even if you said, oh, I want to call this the benzene ring, so I want to call this benzene, but then I want this to be added on, well, that's fine, but how are you going to name that as well? Because that stuff's been attached not at the end, but in the middle somewhere, okay? So you kind of have to look at it and decide, is that a long chain of carbons and with a phenyl group attached to it, or is that a benzene with a little bit of carbons attached to it, okay? And like I said, how are you going to describe this? How would you describe that as an add-on group? Well, you can't, because you really have two parts here. You got this chain here, and then this methyl coming off here, but it's not at the end, it's in the middle somewhere, okay? So in that case there, with this one, this is the benzene ring, this has got to be a phenyl group here, okay? So there's a little bit of difference there that you have to be aware of, okay? Go ahead and draw those. And yeah, we'll give you a little bit of time. Okay, so when you're doing these, look here. That's where you need to start. Heptane, that's 7 carbons in a row, single bonds. All right, so 7 carbons in a row. 1, 2, 3, 4, 5, 6, 7. Okay. On the 2, you have a methyl, and 3, you have a phenyl. So let's put a methyl group on here, and 3, I'm going to put a phenyl group on here, and I'll fill in the rest with H's, of course. Like so. Okay, so that should be your 2-methyl-3-phenyl heptane. The next one is actually this one here, and it's also on the back page here as well. And on the back page it says, I don't need you to write out a balanced chemical equation, but this is eventually something you need to do. So, we're going to have a little competition. Who can tell me, all I want to know right now, after you've drawn it, you have to draw it first. After you draw it, you can either copy it over, whatever, doesn't matter. But I need to know the chemical formula of 3-ethyl-3,4,5-triphenyl oct-1-ine. The chemical formula. So C something, H something. There's only C's and H's in there, so there's only 2 things you need to worry about. So go ahead, tell me. You don't have to worry about the equation for quite yet, but I do want to know what the chemical formula of that is. Okay, pay attention here, guys, because this is important. So oct-1-ine, triple bond. Of course, remember, you got to start there now. You got 3-ethyl, 1, 2, 3-ethyl, and 3, 4, 5 have triphenyls. So I'm going to put one here, and one here, and one here. Okay, we need to fill in the rest with H's, of course. So, got 3 there, I need 1 H. Got 4 there, got 4 there. 1, 2, 3, 4. 1, 2, 3, 4. 2, 2, and 3. Okay, so that's what you need to have before you can start counting them up. This is exactly what you're going to be doing eventually in this unit, because you are going to tell, I'm going to tell you, you're going to have 25 grams, for example, of, what did I say, 3-ethyl, 3,4,5-triphenyl, 1-octine. What's the enthalpy change associated with this? Or what's the molar enthalpy? Or use Hess's law, or something like that, all right? So you need to be able to do this, obviously. This is where we're going to eventually here. And we need to get the right formula. So let's see here. Let's count them off here. 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10 so far down there. Okay? Up here, remember, every junction here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So another 18 there, so that is C28 so far. Okay? Now, this is the part that we usually can potentially mess up. Pay attention. H. How many H's do you have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 so far. Okay? remember what benzene looks like. That's why I drew it out earlier. When you do a phenyl group, there's only 6 bonds. There's 6 carbons connected to 6 hydrogens. If that's the case, how is it going to attach to this carbon? You got to take off one of the hydrogens, correct? Because remember, there's a hydrogen here, there's one here, there's one here, there's one here, there's one here, but there's not one at the end of here, because if there was, I couldn't attach it to the carbon, correct? So there's only 5 hydrogens there, okay? That 6th, where that 6th one goes, is what's attaching it to this carbon, yes? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So there's another 15 there. So that's a total of 30. Okay, altogether. Yep. Well, usually that's benzene right there, right? C6H6. But if I want to hook that up to the carbon, I have to take off one of the hydrogens, right? So I got to take off that hydrogen there. So normally it's C6H6, but in this case it's C6H5. That's the phenyl group because it's got to attach itself to that carbon. So that's the chemical formula for this entire thing.
Yeah, but it's still benzene, so it has 6
Well,
hydrogen, so what happens to this hydrogen?
no, there is no, that hydrogen was never there because it's being added on to the carbons. So that hydrogen is not there. It is just basically adding on to that carbon chain, the phenyl group, okay? Now you got to do a balanced chemical equation with this. So combustion last thing here, guys. So balanced hydrocarbon combustion reaction. 28 carbons, 30 hydrogens. I'll tell you right now, if I go ahead and put 28 there, that's fine. I'm going to get an even number of oxygens here. But when I go to put the 15 hydrogens there, or sorry, the 15, that's going to give me an odd number there. So basically, you know, if you don't want to do that, that's fine. Well, you know what? Maybe I'll just do that. 28. I'll put 15 here. That's going to give me an odd number. So that's what? 28 and 2 oxygens is 56. And another 15 is 71. So half of 71 is 30 and a half here. I'm going to have to go back and double everything. So 2 71 oxygens, need 56 carbon dioxides, and 30 waters would be the correct balancing there for that. 2, 71, 56, and 30. Sorry. 35.5. There we go. Okay. But it still works out to be 71 there. Okay. Good? Questions, anyone? So, once again, that's important because you're going to have to be able to do that. Got a worksheet for you that I'll give you, and we'll